Well, I trust you did well on your quiz. Students in here felt like they did fairly well on theirs, and we'll take a look at those in our next lesson. I want you to find your notes from last lesson. We did this problem. It was number 24. So maybe in your notes you find this problem. And what we ended up working was we had to change cosine squared into 1 minus sine squared. And then we combined our sine squareds together, and we got a really weird value. I think it was like the square root of 2 plus square root of 3 all over 2. And we had to plug it into the calculator, and we found our reference angle to be 75 degrees. And because of a positive negative, we said it was going to be in all 4 quadrants. And so we got for our answers 75, 105, 255, and 285 degrees. Do you find that in your notes from the last lesson? There's another way we could have done it that is, in some ways, easier. So I want you to rework. Actually, just watch on this one. We'll give you a chance to redo a couple problems with me before we wrap up. What we could have done here is we could have factored out a negative 2. And if we did, that would make this a negative sine squared beta and a positive cosine squared beta. And that's interesting because cosine squared beta minus sine squared beta,
1.
If you go way, that would be plus, would be 1. If you go way back in your mind, this is the double angle identity for cosine. So we could write this as negative 2 cosine 2 beta equals square root of 3. We could use a double angle identity here. And of course, if we divide away the negative 2, we get that cosine 2 beta is negative square root of 3 over 2. And notice we've isolated the trig function just like that. Well, when is cosine square root of 3 over 2?
30.
Yes, 30 degrees. When is cosine negative?
2 and 3.
Quadrant 2 and quadrant 3. So our reference angle is 30 degrees in quadrants 2 and 3. So that means that 2 beta, notice, not beta, but 2 beta, is equal to quadrant 2 form of 30 and quadrant 3. But that's 2 beta. I just want beta. So I have to do what to both numbers? Divided by 2. And that'll give me beta is equal to? And you'll notice that's 2 of the answers you got for number 24. But wait a second. We got 4 answers, didn't we? These answers only came out to quadrants 1 and 2. Because if you're staying between 0 and 360, right, if you cut it in half, the best you can do is the first 2 quadrants when you half it. So what we're going to have to do is apply the coterminal angle rule so we get a second set of values. So here's set of answers number 1. I'm going to add 360 to both of these, and that's going to give me 510 and 570. This is the first round. This is the second time around the Cartesian plane. Does that make sense? And so I've divided these by 2. Now I'm going to divide these by 2 to get 255 and 285. And there's the other 2 answers. Does that make sense? I want you to write this in your notes. If you have an n theta value, if you have n theta, obviously this was beta, where n was 2 and the theta was a beta, right? But if you have n theta, you're going to have to add 360 degrees n minus 1 times. In other words, you need to go around the Cartesian plane as many times as you have the coefficient. The first time's already going to be there for you. And then if there's a 2, you have to do it 1 more time. If there's a 3, you're going to have to do it 2 more times. That was like a 5 beta.
This is pretty simple.
You're going to go around 4 times, right? Just adding 360. Calculator comes in handy. And then divide by n. In this case, dividing by a 2. So we're going to begin working with multi-angle values, where the only real trick is go ahead and go around again, or go around a couple times. Write this down, if you would, please. 2 sine squared 2 alpha minus 1 equals 0. 2 sine squared 2 alpha minus 1 equals 0. Like any trig equation, we want to isolate the trig value. So first thing we're going to do, class, is add the 1, then divide the 2, then take the square root. And when we do, we're going to get the sine of 2 alpha is equal to, well, we can take the square root of 1, we can't take the square root of 2, so we're just going to leave it here. We could say square root of 2 over 2. I don't really want to, but it was my idea to take the square root.
Positive, negative.
Positive, negative. So we ask ourselves, when is sine opposite over hypotenuse 1 over square root of 2?
45.
At 45. And ASTC, class, all 4 45s. But notice, this is going to be 2 alpha is equal to 45, 135, 225, and 315. But if you cut these all in half, when you divide by 2 to get plain old alpha, right? When you do that, you're only going to have the first 2 quadrant answers. So because there's an n in front of your theta, you're going to have to add 360 n minus 1 times. So n is 2. We're going to have to add 360 1 time. Does that make sense? To all of these. So let's add 360.
405.
495. 585. 675.
And all of these get divided by 2. Calculators at the ready, potentially.
202.5.
22.5. Oh, I see. You know all of these, all 8.
Oh, okay.
So you did this one, which is 202.5 degrees.
67.5. 112.5.
He's doing this without a calculator, by the way, for those on YouTube. The rest of you can jump in if you want.
I'm just trying to write it down.
117. No. 1. I don't know. I'm just gonna
All right, that's fine. No problem. That's why we have calculators.
157.5.
Let's take it around.
All right, then we already got the 202.5. What about 495 divided by 2?
247.5.
285 divided by 2?
292.5. 337.5.
337.5. And there are my 8 alpha answers.
Now I gotta write those down.
All right, but do you see on the initial step, it's just like all the trig equations we've been doing. The only difference is, instead of being done here, we had to cut them all in half. But also, we had to add 360 and cut those in half. That's the little extra step we're working on now. Write this one down if you would, please. Tangent 3 gamma equals 1. Tangent 3 gamma equals 1. Now this one's really straightforward on purpose. I've already got the trig function isolated. So all you have to do is answer, when is tangent opposite over adjacent 1 over 1? 45. And ASTC, when is tangent positive?
1 and 3.
1 and 3. So that means that 3 gamma is going to equal
45 and 225.
But I've got to go around the Cartesian plane how many total times? 3 total. I've already gone around once. I've got to go around 2 more times. Right. So that means I'm going to add 360 to these.
Why was that 720?
Hold on, I got to add 360 to these.
405 and 585. 2.
And then I'm going to add a 360 again, or add 720 to the original. I think it's easier to add 360.
765. We're using calculator for this one.
945.
Wrong.
No.
745. You're adding 360. All right. Those are all 3 gamma. I don't want 3 gamma, I want gamma, right? So what do I have to do now? Divide all 6 answers by 3. 45 divided by 3?
15.
15. 225 divided by 3?
75.
405 divided by 3?
135.
That doesn't sound right. Is that right? 405 divided by 3?
135.
135? Okay. 585 divided by 3?
195.
765 divided by 3?
225.
What is it?
225. 225.
I had 255.
220.
765 divided by 3? 2. I'm getting 255.
255.
And then 945 divided by 3.
315.
And those are my answers for gamma. And my lecture is covering some of the answers. All right, that's the only new thing we're really working in this next section as we progress to 7.2. I'm going to try a few of these for homework. I know we didn't get very far, but give these a try. Page 144 to 145. I want you to do numbers 1, 3, 7, and 18. So just try those 4. We'll go over a lot more tomorrow in our next lesson. But for now, let's see how we do with these 4. We'll also take a look at your quizzes in our next lesson. Do have a wonderful rest of your day, and you are dismissed.